Greetings, everyone. My name is Alex Zagievsky. I am a Senior Solutions Architect at Winslow Technology Group, and I welcome you to the first episode of Tech Talk. This is the first of many in a new series of conversations covering current and relevant technology topics. The focus here will be more so on the technology rather than products or services, underscoring Winslow's overall strategy to be a consultative partner who provides holistic solutions rather than just scanning individual SKUs at a cash register. And as a special bonus, all of today's attendees will receive a $10 Dunkin' Donuts gift card. So for those of you joining us for the first time, Winslow has been in business for over 16 years as a technology solutions provider headquartered in Waltham, Mass, with satellite offices in Charlotte, North Carolina, and New York, New York. Our goal is to identify and develop expertise in game-changing technologies like the ones we'll discuss today, and then implement them for our customers, like you, through partnerships with today's leading technology vendors. And let's not forget that cybersecurity, with its own menu of goods and services, looms over all elements of technology. But enough sales talk. Let's talk tech. Today's hot topic is infrastructure as code, also known as IAC, and how it relates to another hot topic, the multi-cloud. With me today is Winslow's Chief Technology Officer, Rick Gowan. Thank you for making the time to shed more light on these topics, Rick.
Thanks for having me, Alex.
Thank you. So I've heard the expression multi-cloud thrown around a lot lately, but what is it and why should we care?
Yeah, so I think when we're talking to our customers, what we're hearing is frequently we've got this sort of notion that multi-cloud means combining different hyperscalers, right? So AWS and Azure, AWS and GCP. And while there's a bunch of valid reasons for that, we also want to introduce this notion that what we're calling multi-cloud nowadays may also extend to on-prem data centers that continue to exist for a variety of different reasons that maybe we'll talk a little bit more about. So we're not just talking about, hey, let's use two different hyperscalers, right? They're going to be completely different platforms. There's a whole nother world out there, and it's really about having the flexibility and portability to move your workloads to different environments. It's less about what do those specific environments look like. Recent study showed that 83% of enterprises currently have a multi-cloud strategy. And I think what's really interesting about this, if you build the slide out, Alex, is that multi-cloud strategy, in more cases than not, and I think there's probably one more, Bill, in more cases than not, is not about combining multiple cloud providers. Now, on average, your enterprises today utilize 4 to 5 different cloud providers, which is something that none of us really expected on day one, I don't think. But what we're kind of here to talk about is how the value is not about extracting 2 different hyperscalers, right? The value here is really about making it so that your infrastructure is portable, your workload is portable. So whether it's AWS and Azure or AWS and your own on-prem private cloud, you're equally equipped for both of those scenarios. So, a couple things that sort of resonate with me in terms of why we need to do this, right? One of the things that keeps on coming up is data gravity, right? You can't change the laws of physics. There are simply applications that work better when they're closer to their workers. We're coming up with all kinds of clever ways to work around this, especially now with COVID, right? We're seeing a lot of remote desktop and virtual workforce technologies. But what we're seeing is that over time, you're going to find certain applications that work great remotely and find certain applications that don't. Today, there's workers all over the world who have apps that work great for them, working from home, and have apps that don't work so good. So the whole concept of data gravity is an important consideration here. Financial leverage is also important. What we're talking about here is being able to leverage multiple providers to get the best pricing. You do it when you shop for cars. Why wouldn't you do it when you shop for cloud providers? One of the reasons customers don't employ this today is because they don't have the ability to abstract that underlying provider from their infrastructure. And so when you build something that's so specifically for one platform and you can't move it, you're locked in. You have no ability to create any financial leverage. So this is a good reason to develop a multi-cloud strategy from day one so that you can employ this financial leverage in the future. Fault tolerance, right? So, I think the classic example right here is GCP being a part of this market. They're kind of famous for killing off products, right? If they made a comment a couple months ago to the effect of, if they weren't number one or number two in the space within a certain amount of time, they would leave the market. We've all also, probably everybody on the call, has been the victim of one of their favorite Google products being end of life. So this is just something from a fault tolerance perspective. Hey, if you're going to build something specifically for one platform, it's another downside of lock-in. Data governance like GDPR, data sovereignty laws across the world and across the country. These are also reasons where you might end up needing to deploy across different cloud providers. So, certain states, certain municipalities have data sovereignty requirements with regards to, data has to be stored within the state or within the country or whatever. You may not necessarily have regional data centers available in those particular localities for your chosen cloud provider, which could lead you to require a different one. I think in terms of looking at this as a broader strategy, not just comparing your hyperscalers, I want to make note of how very important hybrid architectures are and how they factor right into this. If we look at VMC on AWS, which is running VMware on AWS, that exists purely to support hybrid architectures, right? That's a big splash, but there's no reason to run VMware on AWS unless you're doing it to connect or interoperate with another VMware environment, right? You don't just run an isolated VMware environment in AWS for fun. You lose a bunch of functionality, it's expensive, all that stuff. That exists to support hybrid architectures. AWS Outposts, that also exists to support hybrid architectures. GCP Anthos, Azure Stack, all of these different products that the hyperscalers have brought to market exist specifically to address this need, which is a hybrid cloud environment. Now, the reason I want to kind of underscore that is because hybrid cloud is multi-cloud. They're not really different, right? Anytime we're talking about leveraging our infrastructure, our platform, our services across multiple different clouds, whether they're public, private, we're talking about multiple clouds, and really the same principles apply.
I was going to say that's a really, really great point. And I think a lot of folks might not even realize that your question there on this slide, are you already using multiple cloud providers, is somewhat rhetorical, especially for anybody who has actually crossed that line into hyper-converged infrastructure. Not without realizing it, they're already in a multi-cloud, aren't they?
Yeah, and I think, one interesting anecdote here is, like I mentioned earlier, the average enterprise is using 4 or 5 cloud providers. And hey, you're probably using Office 365. Lots of people are using Office 365. It's one of the most popular, collaboration suites. And then the most popular public cloud provider is AWS. Well, guess what? You're multi-cloud, right? And the extent to which you're leveraging those capabilities and, intelligently managing across those different platforms is going to, majorly factor into your long-term strategy, right? Are you multi-cloud in an accidental way? Or did you deliberately set up the tooling to position yourself for managing across those different platforms at the first place?
Right. So all of that makes sense. Sounds to me like there's a lot of moving pieces, possibly even without intending to be so. So where do we begin? I mean, is this where infrastructure as code fits in?
Yep, it does. Yeah. So did we just skip a slide?
Sorry, I had to go one back one.
Okay, cool. So yeah, one of the kind of things that we think is foundational to having an intelligent multi-cloud strategy, what I'm talking about there is on day one, set yourself out for a multi-cloud end game, because that's where you're going to end up, whether you realize it now or not, right? And so the difference between somebody who gets there by accident and somebody who gets there on purpose is planning to be there at the end. With most enterprises choosing or ending up with a multi-cloud environment, that might not be something they set out for on day one. So they find themselves with these different pillars, these different silos that are completely not related. They don't have the tooling to abstract those layers. And all of a sudden, they've sort of recreated a very old school mentality where you've got different groups with different skill sets supporting different parts of the environment, right? That's what an accidental hybrid cloud looks like. You don't have mobility between the platforms. When we set out to do this intentionally, when we say, hey, you know what, odds are I'm going to end up using multiple providers. There's a lot of good reasons for it. I'm going to build my tooling to accommodate multiple cloud providers. And we believe that the foundation to start that strategy begins with infrastructure provisioning. That's where a lot of this stuff sort of starts. When you're making your cloud journey on day one, you're probably doing it with IaaS, and you're probably going to manually provision that stuff via the console. So instead of building up those skills and building out that environment that way, let's take a step back. Let's do this intentionally, and let's start with provisioning infrastructure with reproducible infrastructure as code practices. At first, it'll take you a little bit longer than just doing it the old-fashioned way, right, which is the console or the CLI. But in the long game, it's going to be worth it. So what exactly is infrastructure as code? This is about managing and provisioning your infrastructure using text files, essentially. We're calling it code, but this is not like a super complicated programming language. It's not like I'm going to ask you guys to learn how to write complex applications. It's really more of a markup language. It's almost like an XML or a YAML or something like that, where you're really just defining what is in your infrastructure. And so we're going to use that to configure all of our hardware and all of our virtual data center, all of this stuff using this set of text files that really defines the environment. So if you can imagine, instead of typing 100 commands into the CLI, you just feed this paper, if you will, into the reader, and it spits out your infrastructure on the other side. I'll kind of explain why that's so important here as we go.
Okay, so I'm putting some of this together, and now I'm actually worried that we're going to have a ton of different tools to manage a lot of these different cloud providers, whether it's private, public, on-prem, in the cloud, intentional, unintentional, and then obviously to come up with the reproducible, consistent results. It sounds like I may have to do a lot of the same things and try to keep them as close together as possible. A lot of companies these days do not have a ton of IT resources, not to mention they also have to meet compliance requirements and so on. Will infrastructure as code change what we have today that sounds like a total jumble into something better tomorrow?
Right. Yeah. And so this is the whole point of it, right? So today, when you're especially talking about a multi-cloud environment, you have a different tool set and a different way of doing everything in each location. You have one way of building out your VMware environment, one way of building out your AWS environment. If you're using Azure, you've got another set of tools there. Each one has a completely disparate set of capabilities and ways to manage it. So let's just take an example. Let's take the two most popular platforms for your private clouds and for your public clouds. Those are VMware, obviously, and AWS, right? Two biggest things. So very, very many companies use both of these. And how do they do it, right? You want to create a new VM, you log into vCenter, you use the UI to navigate to your data center, your cluster, you create your VM, maybe you use the template, you fill out that form, VLAN storage, all those different settings, and you deploy the VM. Do you have to move around some VLANs on the network side to support that? Maybe you do, maybe you don't. You do all that separately. Maybe there's some firewall rules. Somebody thinks through that and does it, right? And that's second nature. That's how we do it today. Meanwhile, that same company, somebody else probably logs into the AWS console, does almost the exact same thing, right? The difference between deploying a VM in vCenter and launching an instance in AWS is not very different at all. And yet, you're executing almost the same techniques, the same end result, and you're doing it using two different skill sets, using two different tools. And how do you maintain consistency across those? How do you keep track of those two different environments when they're audited completely differently? They're managed completely differently. How do you get repeated, consistent results across different environments? And add in more if you want to. Add in Azure, add in GCP. That's not easy, right? So that's what we're kind of looking to solve.
I was going to say, and right now, currently, unless you sit down and you script it out literally step by step, click by click, with screenshots, there really is no way of writing any sort of like an orchestrated methodology for accomplishing all of these things manually.
Right. So here is where what we want to do is start to talk about how infrastructure as code solves that problem. First off, there's a little example on the left. That example there, provisions an instance in AWS from a particular kind of template, if you will, to a particular size of VM, if you will, like how many vCPUs and memory and stuff, right? Kind of looks like programming code. But there's not a whole bunch of logic and all this stuff. It's really going to be more similar to a markup language. One of the nice things is that we can do this in every provider, right? So every time you run this template, you get the same results. What we're talking about here is if you can just feed that piece of paper in every time, you're going to get the exact same configuration every time. The reason that's important is that, remember, we just talked about last time and on the last slide, you're filling out those forms manually and you're putting all different things in there. And, maybe you stuck this one on the wrong VLAN. Maybe you opened the wrong port on that one. By putting all this stuff into a document, we get this consistent, self-documenting view of our environment. And I'll get a little bit more into, why that's important here as we go.
Great. So yeah, so that does actually look a lot easier, cleaner, and you're absolutely right with the curly braces, especially. It kind of reminds me of coding in C++ back in the day. So what about the multi-cloud? I mean, does IAC address that nicely too?
Yeah, so here's where, hopefully this comes together a little bit, right? I just showed you, you've got this infrastructure as code document. You're able to lay out your environment. Now, when I say infrastructure as code, there's a million different tool sets. There's a million different flavors out there. When you know that you're setting yourself up for a multi-cloud environment, our advice is to leverage an agnostic toolkit, a cloud agnostic toolkit for management, for doing that infrastructure as code management. Why, right? Okay, so AWS has CloudFormation. That is going to let you essentially implement infrastructure as code practices in your AWS environment. Great. Now we've solved some of our problems in our AWS environment. Doesn't do anything for our VMware environment, for our VMware private cloud, right? Doesn't do anything for us if we want to move into Azure or GCP. So what we kind of advocate here is that when you're looking at a future that includes multiple clouds, especially one that includes a private and a public component, we like to take a step back and kind of, rather than using VMware's tools and AWS's tools, let's look for something that works across all of those. Now what we're able to do is manage every environment with a consistent tool set, right? So instead of having 3 different silos with 3 different skill sets, poking around in different consoles or learning different CLIs, we learn one markup language, and we can apply that across every single cloud provider we could want to use. And we're going to apply the same processes, rigor, change control, management, auditing, all of that stuff will work exactly the same for every single provider, every single shape and form of cloud we might want to use. So this is why, while infrastructure as code brings a whole lot to the table, we also feel it's important to try and take a step back and be cloud agnostic. By the way, just so there's no confusion, I'm not trying to sell you Terraform or any of this stuff. It's free, right? This is an open source product. We just advocate it as a strategic way to get started in all of this, because in the long run, you might find having the flexibility to not be locked into one particular tool set or another to be really valuable. So some of the other stuff, I want to talk a little bit more technically about infrastructure as code here. Everybody's heard of these tools, right? Chef, Puppet, Ansible, Terraform, CloudFormation. Let's talk a little bit about what's the difference and why those differences are important. Cool. So I'm going to break these up into 2 big buckets here to start, and we're going to make more buckets as we go. First, configuration management versus provisioning. Configuration management is going to be the things that build your servers, right? Build your images. You're going to use Ansible to build images. Now, granted, I'm putting these things in the buckets. They don't like entirely fit into all of the buckets. You'll see this as we go. Like I had to draw some lines here. There are provisioning activity you can do with Ansible, and there's config management stuff you can do with Terraform, all that stuff. But just generally speaking, two big categories: config management and provisioning. Config management is what you're using to build your images, build your servers, right? Provisioning is what you're using to deploy those servers. So think about, for example, a common kind of thing is you're using Ansible to build your image, then you're using Terraform to deploy that image. So these two things can work together. They don't really, they're cooperative, right? It's not really like they compete with each other, if that makes sense. So it's going to be pretty common to use some from column A and some from column B, and I think it'll be kind of helpful to think about them in these buckets as we go forward.
Cool. I was going to say all of that makes sense. And when you're talking about a lot of these tools, one of the first things that jumps in mind is containerization, where you have elastic environments that expand and contract as a infrastructure and therefore business needs also dictate it. How do these fit in?
Yeah, so a lot of these different tools have support for container and container-based builds. Certainly on the provisioning side as well as on the config management side. You're going to have a different workflow and a different work stream when you're talking about building, physical server images or virtual server images versus building container-based applications. But at the end of the day, we're able to leverage these along with even some other options when we're talking about container-based workloads. Cool. So this is kind of important. And the reason this is important is because this actually impacts what you get out of these technologies. Okay, so this is when we're talking about infrastructure as code, there's going to be some products that we would consider to be procedural and some products that I would consider to be declarative. And again, these are buckets that not everything completely fits in. There are some from column A fit in column B and vice versa. But as a general practice here, think about these two categories, procedural and declarative. Procedural means essentially step-by-step instructions. So think about when you go to a burger joint and you order a burger. You say, if you order that burger as, okay, first take out the bun, take a patty, cook the patty, place patty on bun, add condiments, right? Package that burger and then hand it to me. That would be a procedural way of ordering a burger. Your end outcome is the burger and you tell them how to get there, right? Declarative would be, hey, give me a burger, and then you assume that the dude who took your order knows how to make a burger. He knows the steps to get to the end result. So you're declaring your outcome, not the process to get to the outcome. So this is important. I'm going to say procedurals are kind of encouraged by Chef and Ansible, which is to say that, there are declarative aspects to it. And part of this is about how you are approaching your builds, right? But so, in something that's procedural, something like the order matters, right? The order of you can't say, put the patty on the bun and then cook it, right? That doesn't come out the same as cooking it first and then putting it on the bun. So order matters. With a declarative, specifying your end state, the tool figures out how to get there. It's going to figure out order. So I think that, the classic example here is imagine a procedural script that creates 10 servers, right? It goes through, it creates servers 1 through 10, boom, done. You got 10 servers at the end. Now, what happens when you run that script again? Boom, creates another 10 servers. Now you've got 20 servers, right? So your procedural file goes through, it creates 10, you run it again, you get another 10, you run it again, you get another 10. Okay, cool. A declarative file that targets an end result of 10 servers, you run it once, you get 10 servers. You run it again, it says, hey, I already have 10 servers. You still end up with 10 servers. In a declarative world, if you order a cheeseburger and you did it twice, you end up with just the cheeseburger you asked for. In a procedural world, you end up with a new one every time you order it, right? So we're talking about an outcome versus a process. Hopefully that makes sense. And the reason this is important is that it essentially means that things that fall out of that end result may be adjusted to get there. So for example, if you have a procedural file that's targeting 10 servers, and then you delete one server, and then you run it again, at the end of that, you have 19 servers. With declarative, you would say, all right, I created 10 servers, then you delete one, then you run it again. It would add the one to make up 10, right? So hopefully that's clear in sort of how they arrive at places. And this has a lot of impacts in terms of like configuration drift and things like that. Hopefully that makes sense.
Yeah, that actually made a lot of sense, and I'm reminded of my time on the user side. Being a customer and working in infrastructures, especially in regulated industries like finance. So the two things that jump to mind immediately is in larger organizations, you have the concept of change management, which is something that's absolutely critical. If you have a lot of chefs in the kitchen, as it were. And then the other thing too is compliance and auditing. This would be absolutely invaluable in both of those, wouldn't it?
Yeah. So one of the, I think, big values that infrastructure as code practices can bring to an environment in general is drastically improving both change management and documentation.
I was going to say, there's that old concept of, well, this is where our infrastructure started, but then we audited it 6 months later, and it is nowhere near where it was because nobody bothered to update the documentation.
Yep. Yeah. So, talking just a little bit more about that, when, it's generally speaking, from an infrastructure as code perspective, the best practice is to not have documentation, which is to say that your infrastructure as code, your markups, your files, if you will, those are your documentation. Because we're talking about, if we're using a declarative tool like Terraform, that means that whatever is in that document matches the end state, right? That's one of the differences with procedural. With procedural, when you look at that, that doesn't necessarily match the end state because you might have run that script multiple times. Over time, you might be getting slightly different versions. Somebody might have added something in, and then you ran this on top of it, right? The end state doesn't look like your script. With declarative, your end state will always match what you started with your script, right? With your markup. So from a documentation perspective, you don't really need to document it because all you have to do is look at those files, and as long as you are, enforcing some rigor around how you manage those, then we're going to always have a match there. And, if I could kind of summarize, like, the whole purpose for this is if you think about how things are done in the cloud today, right? Everything's become software defined. These tools, such as CloudFormation, are a critical component of operating out there in the cloud. And what we're sort of saying here is, hey, everybody agrees that stuff makes sense out in the cloud. How come we're not applying those same practices internally? And that's what infrastructure as code lets us take a step towards doing. The other thing is, from a change management perspective, like you mentioned, change management is something that many IT people work around and see as an enemy, right? I know that coming from large enterprise backgrounds myself, change management was just something I had to fool in order to get my job done, right? And so I knew darn well that there was nobody reviewing my changes that really understood them. For example, every single change would ask for a rollback plan, and those were very rarely tested or could work. Infrastructure as code makes all of that stuff so much easier because we can start to implement some of those checks from a change perspective right into our code, right? So we can, before something gets deployed, check, make sure it's not opening a port it's not supposed to. Before it gets deployed, check, make sure it's not deploying into a region it's not supposed to. All of a sudden, we take the human element out of this. Humans perhaps don't even have the rights to make any of these changes themselves, right? So everything is documented in text, plain readable, and you can run different tools to check and make sure that those things aren't doing anything they're not supposed to, right? So from just enforcing change management and having good big IT hygiene, infrastructure as code, it takes you so far down the line, is really, really beneficial and something that I could spend another half hour talking about, maybe at some point in the future. Cool. So a little tangent there, but one of the things as we kind of come into the final stretch here, we're just kind of trying to offer you guys some suggestions to get started with infrastructure as code in a way that you're likely to be successful. Let's be honest, when you're first starting with this stuff, you're just going to be copying and pasting other people's markup and seeing what it does in your environment. So you're going to find it to be drastically easier if you're using stuff that everybody else uses, right? So if you're trying to use Terraform in AWS, those are two of the most popular tools out there, right? Terraform is a massively popular provisioning tool. AWS is the most popular hyperscaler. Use those things together. You're going to find an example to do anything you could possibly want to do. Now, if you try and do that same thing with a less popular provider, you're going to have a lot harder time finding examples. What we would suggest is start by working with the most popular stuff that's in your environment. If you use VMware and AWS, you're golden. That's what everybody uses. As you start to stray from that, you'll find things get harder and harder to find examples to find support for. And this isn't to say that you can't use other things. It's just going to be more work for you. So our suggestion is to start with the things that everybody else does, because that's going to allow you to learn the basics. Then you can start branching off into incorporating, your Juniper switches into this, whatever other odd examples of infrastructure somehow ended up in your environment. Start with the stuff that's easy. Now, the other thing that's important here is the more integrated your environment, the more you can automate. Think about this in terms of, you're going to have a block of markup for every component in your environment. So if you've got servers, networking, and storage, you're going to have to automate each one of those kind of separately. On the AWS side, if you've got different things in different regions, or depending on what services you're integrated, all that stuff adds complexity. So the tighter your environment, the less management surface area you have today, the more distance you're going to be able to cover, the more success you're going to have with infrastructure as code as you get started.
So, Rick, you call it copying and pasting. I call it not reinventing the wheel. But all joking aside, though, you made an interesting point. Actually, something I wasn't even aware of, not at great depth. It sounds to me like IAC is useful in more areas than just controlling your hypervisor and your cloud-based virtual environment. Sounds to me like there's other pieces of equipment that will nicely interact with IAC.
Oh yeah. And from an end state perspective, you want to have as much of your environment as possible encapsulated within those documents. And so, especially if we're talking about something like an AWS, we're going to build out every aspect of the network, every aspect of the storage. Same thing with VMware. We should be able to, we can provision storage, we can map it up to our hosts, and the entire environment will be encapsulated. It's definitely not just about creating VMs, creating guests. We can be creating VPCs and subnets in them, just like we could be setting up storage. Cool.
So I guess going back to a point that you made a little bit earlier regarding software-defined data centers, this sounds like this is the next big thing. That this is to virtualization and so on, as virtualization was to data centers.
Yeah, I think that this ends up being, an important part of a lot of people's strategies. And it's definitely going to represent not just, the problem is that it's not just a change it's not just a change of what tools you're using or what storage you're buying or whether you're on-prem or cloud. All those questions are kind of smaller, right? This is more about how do you do business internally? This is going to should fundamentally change how our IT groups are organized, how we approach making changes in our environment, how we approach decision-making in terms of, cloud providers and where things are placed. This abstracts so much of the troublesome aspects of infrastructure management that, foundationally, this is just as much about people and policy as it is about actual technology.
Nice. Yeah, that's actually a really great way to just kind of sum it all up. And it sounds like with technology in general, well, the underlying hardware at any rate, becoming so commoditized, sounds like the one way that one can differentiate oneself, be it as a provider or as a technologist, is grasping the concept of infrastructure as code, becoming familiar and very adept to it so that you can essentially work with any underlying infrastructure. So that being said,
Right.
where do we begin?
Yeah. So I think one of the first things that might, there's a typo. One of the first things that might help here is, if you want us to come in and give you a demo of Terraform or other infrastructure as code products in your public or private cloud environment or in ours, happy to do that. I can whip out some quick demos to show you, for example, how a nice declarative infrastructure as code tool is going to locate security holes in your environment and automatically close them. And that's not by me saying, hey, go find security holes. It's by me saying, hey, apply our original baseline. Find out if anybody made any changes that perhaps open security gaps, and the system will automatically close them because that's how declarative systems work. We can automate the provisioning of an entire environment. We can check for configuration drift. We can enforce company policies such as data locality, GDPR regulations, other sorts of regulatory requirements. We can automatically check for those. And this is all stuff that we can do in a really reasonable amount of time. So I think a good first step here is watch a demo of what's possible with infrastructure as code, especially with a powerful provider like Terraform. And I think that once you kind of take it from the abstract, right? I'm kind of giving you a pretty abstract look at this. Once we make this practical and you see how it actually benefits you in your environment, you're going to want to learn more and you're going to want to do more with it. So definitely suggest, reach out and ask for a demo of this stuff and see it firsthand.
Yeah, so you said it was abstract, but I'll be honest, your concrete examples just really kind of solidified it and kind of brought it all back together. And, speaking for myself and probably for many others that are on the line right now, I personally feel very much enlightened on this topic, learned a lot. This was incredibly useful, and I can't really wait to get started with this. So, Rick, thank you very much for your time, for sharing all of this knowledge.
Thanks, Alex.
Now, if everyone would like to learn more about today's topic or our guest, please find him on Twitter at Rick Gowan or browse to ws.rickgowan.com. To learn more about Winslow Technology Group, please visit us at ws.winslowtg.com. And if you're interested in seeing that live demo that Rick was talking about, please drop us a note at webinars@winslowtg.com. So this brings us towards the end of our first episode. We do not have any questions, so we'll conclude this episode of the WTG Tech Talk. Thank you all for joining us, and we look forward to seeing you at the next one on June 24th, when we'll talk about the DoD Guide to CMMC Compliance. Till then, stay safe and keep innovating.